Are you
Yes,
able to
Oliver,
hear
we
me?
can hear you.
You can hear me. Thank you. Thank you very much. We are 1 minute after the hour. I thought that we could start the session now. We have 37 people, but as usual, I know by the time I finish, these numbers will have changed. So I think we should start. Is that okay, Eileen?
Yes, Oliver. I think it's perfect.
Okay, good,
Please
good,
share
good.
this
So,
ready.
good, good, good. I see Richard is here. Good to see you, Richard. Good
Hi,
morning,
good to see
good
you.
afternoon, good evening, depending on where you are. I know that we have many people that are connected from different parts of this world, so it could be evening for some of them could be morning. So thank you again for really for joining us today. But before we start, today I have very strict instructions. Just excuse me 1 minute.
Oliver, you're muted. Sorry.
Yeah, so sorry, I was expected to join another meeting, so I just told them that I'm not going to join that meeting. I just told them colleagues, sorry. Yeah, sorry, colleagues for that. So before I start, I was saying today I have very strict instructions from Elaine, so I will obey those instructions to make sure that this webinar goes as smoothly as possible. So part of the housekeeping, first of all, really is that I want to ensure that all the technical issues are taken care of. Please, if you have anything that you want to share, put it in the chat. And any a member of the team will be able to respond to you as quickly as possible. I apologize if you're going to be having any glitches in the process in doing that. And secondly, really, I want to invite each one of you that is connected that we participate in the discussion and share your comments and questions in the chat box as well. And finally, I want to also let you know that this webinar is actually recorded, and we'll be able to share the outcome of this discussion on the web page, including the presentation that are going to be given. So let me again welcome you. I know that we have various people, as I mentioned earlier on, who are coming from different areas, but I want you all the best in terms of this session today. So my name is Oliver Chinganya. Many of you, I think, know or don't know. I'm the director of the Africa Center for Statistics at ECA. So today, really, I will be the one that's going to moderate this session. So I want to welcome you to this 9th StatsTalk Africa webinar series. The series aims to provide space for dialogue regarding data, statistics, and innovative tools with data experts and users. The session aims to promote better understanding of statistical concepts and alternative data sources such as geospatial information. It is positioned as a knowledge-sharing platform, promoting dialogue among data experts and users. It aspires to unpack complex statistical concepts and terms of better information utilization. The Statistical Talk Africa session invites, first of all ECA colleagues within ECA. We want to invite member states, development partners, colleagues from the academia, those that are associated with data issues that we deal with, particularly in this new era where there's so much going on in the data sphere, so to speak. So welcome, yet again, really a very leveraging kind of enlightening rather session on StatsTalk. This time around, we'll be talking about leveraging GIS and artificial intelligence in solving global challenges and revolutionizing census workflows. We are therefore very extremely pleased to have this opportunity to explore and examine the integration of geospatial and statistical information, with emphasis on the need for data, for better data and statistical measurements to improve the understanding and monitoring of our common agendas. So, what is GIS? What is artificial intelligence? Just to put it in context before Richard takes the floor, Geographic Information System, or GIS in short, is a computer system for capturing, storing, checking, and displaying data related to positions in Earth's surface. By relating seemingly unrelated data, GIS can help individuals and organizations better understand the spatial patterns and relationships. In the meantime, the artificial intelligence, or the AI, refers to the development of computer systems that can perform tasks and typically require human intelligence. These tasks include speech recognition, decision-making, problem-solving, and learning. It is said over the last decade that there has been major integration of artificial intelligence and GIS. So while GIS is powerful technology with extensive data sets and a wide range of artificial intelligence applications, artificial intelligence provides advanced methods of GIS projects. Also, GIS and artificial intelligence have a complementary relationship where artificial intelligence techniques can enhance and augment the capabilities of GIS, with GIS provides the necessary spatial data and context of the artificial algorithm. So with this understanding, before I again hand over to Richard, what are the roles of GIS, again, to put things in context, particularly in the African statistical system? So nowadays, we all know that the geospatial can heighten national statistical statistics frameworks and structures for collecting, processing, storing, and aggregating disseminated statistical test data. The challenge being faced is how best to achieve this integration in an effective and consistent way. It was noted that many national statistical offices are already transforming or are planning to transform their statistical infrastructure, offering an opportunity to embed geography into their statistical processes. As we embrace a new frontier of data, EC has been working with member states to develop a comprehensive program on the modernization of geospatial activities in Africa. The program will serve as a vehicle to mobilize resources, strengthen member states' capacities, and for the integration of geospatial and statistical information infrastructures. We have developed here at ECA a digital census cartography framework in support of preparatory activities for countries undertaking the population and housing censuses. We are providing advisory technical support or assistance to member states to manage their geospatial data and develop geocoding schemes for geospatial analysis for their census data. As you can see, we're doing quite a lot already, but never enough. Countries keep on asking for this and that, and we will continue providing support within our resource envelope. The integration of statistical data or statistics and just information should be seen in the context of a wider integration of data from a variety of sources, reflecting the trends of today's more and more data-driven society in experiencing the big data revolution, characterized by crowdsourced data, image analysis, mobile technology, GPS, drones, volunteer geographical information, cloud-based computing, and the Internet of Things. So, what are the challenges and where do we go from here? African countries face a perennial challenge that statistical data needed to support development requirements is often either not collected or compiled or disseminated in a timely manner. This is due to several impediments that range from insufficient coordination, standardization, and quality assurance to limited institutional capacity, inadequate data management systems, and weak statistical infrastructure. As a result, the quality of data can be compromised. Africa faces various infrastructures, skill-based and awareness-related challenges implementing and adopting sophisticated tools like GIS and artificial intelligence. So today we want to look at very promising issues that combines innovation in spatial science and with the rapid growth of methods in artificial intelligence and big data to enhance national statistical workflows. But before I proceed, let me remind everyone that StatsTalkAfrica is just not a platform passive learning. It's a community, a melting pot of ideas, experiences, and this is why we have Richard today, providing insights as Africa strives forward, enhancing valuable technology and innovations on the pathways for transformation. So we want to explore the realms of new technology like GIS and artificial intelligence in statistics today. And therefore, I'd like to encourage each one of you to really participate, ask questions. Let's have you, share your own experiences and so forth in terms of what we want to do. So at this point, let me inform everyone, first of all, that we have a presentation or someone in Richard who's going to give us his own perspective on how we can leverage GIS and artificial intelligence, solving global challenges and approaching census workflows. For those who don't know more about Esri, which I'll come to when I formally introduce him properly, Esri is a global market leader in GIS, software location and intelligence and mapping, with a tagline that sums up its mission, essentially the science of where. And that's critical, colleagues. So I can guarantee you that, from where we sit in the next couple of hours, I think we'll be able to learn much more from Richard, what he's going to tell us this morning. So the presentation of today will focus on leveraging GIS and artificial intelligence in solving the global challenges and revolutionizing census workflows. Richard Epspen, I hope I'm pronouncing the surname properly, so he'll correct me that, from Esri. Thank you, Richard, for really joining us. Today we're really happy that Esri indeed is a good partner, and we want to push our boundaries to working very close. But yourself too, you're eager, and your desire to work with young statisticians, really something that impresses us very much. So, colleagues, those who don't know Richard, Richard is a global leader on official statistics as Esri. He holds a Bachelor of Science degree in Geographical Information System, has over 15 years of expertise in a realm of geographical information system and software applications. So you can see the person that we are dealing with. He has dealt with a number of areas in the areas of energy, smart cities, and statistics. And he has played major roles, senior roles as project manager and strategic advisor in various ventures. So, Richard, I would like to turn this to you now to take us through your presentation. And over to you, Richard.
Thank you, Oliver. Thank you so much for this amazing intro and about GIS and using GIS along the whole workflow, the GIS BPM process for the statistics workflow, and how it's important to integrate GIS, geospatial data, with statistical data, adding the layer on top of that, bringing AI, machine learning, big data to support national statistic organization and getting the most out of the data that was collected, and see things that it's difficult to see by the eye, and using the machine learning and trained models. So I would like to share my screen with you here to start my presentation with you. And as Oliver already introduced me, so I'm currently at Esri, the official statistics lead globally. I support many statistical organizations around the world, and we have a lot of examples we're gonna see here during the presentation, and we're gonna also, I have some surprises at the end of my slide showing what's gonna be released soon, and where is the technology is heading to, and how Esri is innovating and moving forward with the current market trend and the technology trends that are happening today. So let's start with what Oliver started with. Here is that we call it the geographic approach. What does it mean, the geographic approach? That means geo-enabling each phase of data collection to visualization of the data, dissemination, analysis, in order to take action based on a certain location. Location is critical and is important. By adding GIS to become integrated with other systems, to geo-enable other systems, it's key and important for decision makers and policy makers. As we all know, GIS is applied in many fields. I myself, as Oliver mentioned in his introduction, I have applied GIS in energy, oil and gas, and defense, and supporting municipalities, building digital twins, supporting very advanced projects. Even I was the advisor on NEOM in Saudi Arabia to build a full geospatial strategy for tourism, for utilities, for urban planning and whatnot. So GIS can play a big role in all of that. And one important thing that today I'm excited that I'm leading the statistical team within Esri is that population census, agriculture census, economic census, all of these census that you as a statistic organization conduct is key and sits in the middle of all of that. Without this information, none of all of these fields can really know, or predict, or can take better decisions on how to plan things, on how to avoid a certain disaster or something like that. So moving to here, it's important, as we mentioned in the previous slides, that all of these fields use GIS, and bringing all of this data together, from utilities, population, and collaborating instead of having data in silos, like every organization has its own geospatial infrastructure, it's important to open up and share data or provide data as a service. If you don't want to share the data, share your screen. Sorry, can you see my screen?
Yes.
Yes, we
Okay.
able to see the screen. Thank you.
Okay, I saw a comment, someone saying to share my screen. All right. All right. So it's very important to collaborate, to share, and today this is possible by using and leveraging web services, and to have a distributed and interconnected platform between different organizations, different departments within the same organization, different teams, and different individuals. This is very important, as also Oliver mentioned. Like here we are a community. For like ECA is the core community for geospatial in Africa. This is where you can bring all of the data and bring all of these different organizations and countries to collaborate across borders, also within the country and across borders. This is very powerful to do so. Moving forward here, so GIS and especially Esri platform can digest different type of data. It's not only GIS data. It can be tabular data. It can be CAD, BIM data. It can be real-time data, big data, multi-dimensional data, and all of the data that you can see here. And it's very powerful as a tool and as a platform in order to bring all of this data, analyze it, and provide a certain outcome from this data to solve a certain problem, in order to take a certain decision, to do some predictive analysis and leveraging AI capabilities that comes within that. So other than the data that we have seen, the scattered data, we also can connect with different type of databases. We have basically we can integrate with data lakes, like you can see Apache Hives, Amazon S3, all of these data lakes that is now cloud-based, and you can connect with different SQL database like Amazon, Azure, and all of that. And we can connect also and integrate with cloud data store. So RGS is evolving to keep up with the technology and trends that the world is moving into. This can save a lot of effort and money on organizations to support them in their digital transformation plan. Moving away, and this is very important, moving away from custom to configure approach. As we may all know, digital transformation is a continuous journey. It has a start date. It doesn't have an end date. It's agile. It keeps evolving. It keeps changing. Nobody can say, I have a digital transformation plan for my organization or for the government, and we need to achieve it and we are done. Digital transformation has a start date. Once you embark this journey, it's an endless journey that you keep on evolving and moving forward with the trend to keep up with the latest technologies. And this is where it's important to have a system that is interoperable, and it can be a system of systems. Having GIS, a system of systems, is very important and key here. Now, starting to touch base more on machine learning and artificial intelligence. So ArcGIS is a comprehensive spatial analytics system that can help you to analyze different type, applying different type of analytical process like vector analytics, AI, applying machine learning and AI in analytics, applying data engineering, and using spatiotemporal statistics, real-time data, statistical modeling. As you can see here on the right, you can see a point cloud classification, doing mapping classification, graph analytics, visual modeling, and interactive chart. All of this provide within this platform to have a dynamic and interactive maps that you can interact with. So moving into data science, applying data science. So there are many tools available out of the box within this platform to help you in applying different type of analytics, spatial analytics, modeling and scripting using Python and using notebooks, in order to script and automate the analytic process using raster, vector, and graph analytics. All of these are available, and applying GAI, it's key in analytics in order to explore things in data and the trends that are within the data, that what happened historically till today, so to have kind of a predictive analytics. So looking here at the different type of like analytics that the platform can support, you can see here raster analysis using deep learning, AI machine learning, deep learning analysis, big vector and tabular data analysis, doing real time, getting data real time using our geoanalytical tool, standard vector, tabular analytic, and network. So these are the different type of analysis that can be applied. As we may all know that data today is money. It is only if having the data only without doing anything, without applying and analyzing this data and getting the most out of it, it's just a prestige to have it, but it's very important what we can do with it, what tools we can use in order to use this, to get the most out of this data, and how it can contribute to building a resilient government and empowers government to formulate evidence-based policies. This, in turn, enhances economic planning, infrastructure development, and resource allocation, contributing positively to the GDP of a country. By bringing your data to life, as you can see here, you're bringing the data to life, you're visualizing it. It's 3D, it's real time, it's dynamic, it's interactive. Seeing this data happening as if you're building a digital twin of your country, it helps you better in enabling predictive analysis to avoid future issues. Now, doing analysis, collecting the data as we have seen before, and doing all of these advanced analytics is important, but the most important part is that ArcGIS provides you with the capability to access all the data as mentioned in previous slides for data engineers to do the advanced analytics and use big data tools and open science to conduct machine learning, to enable your apps to be AI driven, to help in detecting data trends and insights for end users to interact and get predictive answers. All of this can be built now, is available within a desktop application or a web application for users available in different parts of the world by providing such application for them to be on a web-based for them. Today, we have a big update to announce to you here on this presentation. As you may already know, Esri and Microsoft has a long-standing relationship and partnership. Today, we already provide ArcGIS to as part of using it as part of Excel sheet. So today, you can have ArcGIS in Excel sheet to bring all the data in the Excel and see it on a map. And you have ArcGIS used in PowerPoints, ArcGIS used in Word document. It can be used in Power BI. So it's embedded inside Microsoft applications. But today, one of the big announcements we have released last year that we're providing our geospatial analytics capabilities within Microsoft Fabric to bring the geospatial component into all-in-one analytics solution for enterprise that covers everything from data movement to data science, real-time analytic, and business intelligence. Today, Microsoft Fabric is one of the most powerful tools that has all-in-one analytics capabilities, as you can see here on the screen, from data access, engineering, and visualization, and real-time analytics. So we're bringing ArcGIS to be part of Microsoft Fabric, as it's already available in Power BI and others. So now touching base a little bit on, as Oliver mentioned, on the importance of integrating GIS and statistical data and how can we apply all of these advanced analytics that we spoke about in the introduction. So as you may all know already, the current UNGGIM, the expert group who came up with this TSGF and 5 fundamentals that brings statistical data to be integrated with this with the geospatial data. Showing here some graphics around how you can bring tabular data and integrating it with geospatial data is very powerful, how it can be integrated into different geographic levels to like districts, provinces, region, and depends on the personas, depend on who you want to disseminate the data for and have it available for. And here we're talking about data accuracy, and data quality is definitely key and important, and AI can play a big role in that. Also adding here another update, that most of statistical data organizations today use SDMX to exchange data between each other. And we are bringing today an extension called Data Pipeline that can help you to bring your SDMX data into ArcGIS and to geo-enable your SDMX data. It's called Data Pipeline. And this can automate the whole process from bringing the data, having it available, and analyzing it. So we see the role of GIS in official statistics increasingly expanding. In the past, statistical agencies would think about use of base maps in the planning of our work, or thematic maps for dissemination. The challenge we all have in front of us now with the integration of statistical and geospatial, the GSGF, is to understand and implement new methods using GIS and spatial thinking. So bringing GIS in the planning and pre-enumeration phase, from the design build to enumeration, to collect and process, analyze the data, post-enumeration, then disseminate and evaluate the data to create information product. So here it's key to touch base on the different planning phases that our statistical and census go through. So preparing your geodatabase and doing in-office canvassing, creating enumeration areas, optimizing capital assets, site placement, and doing mobile map packages to send your enumerators using the mobile application to do so. So how AI can help in this? AI can streamline census data collection by automating processes such as image recognition and natural language processing. Drones equipped with AI can efficiently survey remote or inaccessible areas, improving data accuracy and coverage. So today, instead of sending thousands of enumerators on the ground to update your base map, you can leverage the out-of-the-box GAI capability and train the models based on the imagery that you have access to, or you have already, or you're looking to purchase, in order to update your base map by using machine learning and artificial intelligence to extract building footprint, to extract roads, to extract boundaries, and to do field verification or validation by sending few people on site and reducing risk of having thousands of people to manage on site to update your base map. So this is here at the planning stage using GeoAI capabilities. Now, it's not as simple as that to achieve GeoAI. So basically, you need to have, as we said in the previous slide, you need to have access to imagery. You need to prepare your imagery. You need to do data labeling in order to start to teach the machine how a building look like, how a road look like. And the more labeling you do, the more the machine will be smarter, and the more your artificial intelligence will be more accurate. Then once you have deployed the model that you've trained in production, and you start train and consuming the model and run inference at scale, and then provide feedback to see the accuracy and to see if maybe the model detected a certain lake, saying that this is a building. You need to correct that and need to relabel and label more buildings in order to reach a certain accuracy. And this takes amount 1 to 2 days of work to do the labeling and to train the model. So imagine the amount of time and effort and money that you're saving by applying GAI and feature extraction. Once you are comfortable that your AI model is smart enough and is accurate enough, this is where you can take action, and you can have an updated base map that you can use this model in every census you conduct in the future. This is one-time process. You just need to train it again, but the training the model that you have already done extensive training and labeling won't take as much time as the first time. The more you train, the more it become like more easy to reuse it in different census activities in the future. So moving to field application. So how can we optimize survey preparation. You can implement AI algorithm to suggest improvements in survey design based on the historical performance of similar surveys. This can help optimize the survey structure and increase response rates. So using AI to learn from your previous surveys what went right, what went wrong, using all of this historical data in order for the AI to create for you a new survey form based on lesson learned, based on mistakes that happened before, to have a better optimized process to building your survey forms is today available, and you can implement that into our field applications, which is our survey 123 or mobile field application like field maps that you can help you to do some mapping on the ground. All of this is provided as a service. As you can see here in the middle of the screen, it's the geospatial infrastructure. People today, and I see a lot of statistical organization, even mapping organization in Africa or in other regions, they're still using desktop applications. This is not helping you to move forward in your digital transformation. You have to move to an enterprise solution, to have an enterprise platform that can help you to provide data as a service for different personas, for different users. You have decision makers sitting behind a dashboard tracking the progress of the census. You have field workers accessing the data and updating and submitting the form, and this data is updating the database to reflect on the dashboard to see the progress. So this is very important. All of this can help you to streamline and to harmonize all of this data into one place, and then apply AI in order to do advanced analytics. As you can see here, integrating AI algorithm into the data that you have collected from as we explained before, using object classification, even using crop classification, and in your agriculture census, and using vector tabular like regression, prediction, classification, time series forecasting, and even you can train the model to detect text, to read text from a certain place. If you're taking pictures in the field, the AI model can detect text. Today, if you have a smartphone, you can take a photo and extract text from a certain photo. So AI algorithm can help predict, for example, population growth, migration patterns, crop classification, and demographic changes based on historical data. So using GIS tool, this enables government to plan infrastructure, healthcare, education facilities more effectively. This is also all indicators today for SDGs also. So your role today in order to also to provide input for the indicators for SDGs for the 17 goals is key here. Using AI can fast track and can provide more accurate information to your SDG reporting. So after doing data collection, analyzing data in order, as we've seen, the different type of analysis you can do, now you need to provide information product. This is what we call dissemination. Information product is very important. It usually can be available for different personas. We can call them like citizens, civil society. They can access the data, and a certain data they can view, certain data cannot view. So it's important to invest in a certain platform that is secure and it's reliable, so you can control and govern what data people can access, what data is available for government agencies, what data is available for academia, researchers, and for non-profit organizations or for private sector. So your data today can be provided for all of these using out-of-the-box application like story maps, using experience builder, drag and drop with zero customization, zero line of code, just configurable applications that you can use to fast track dissemination, which most of the statistical organizations today I'm dealing with globally are facing a lot of problems into like they collected the data, they're still stuck and not yet disseminating the data. So what's the value of having data without having it disseminated for different users, for different personas that can help your economy, that can help decision makers, that can have an enhancing policies in a certain area and poverty. So moving to advanced tools that can be applied here using ArcGIS Notebook. So notebook authors can use Esri Python resources, the ArcGIS API for Python and ArcPy, and popular open source analytical, statistical, and machine learning libraries that are available out of the box in order to provide those information products that we spoke about to be AI enabled. So decision makers today, they can consume data and they can use AI without being an AI expert or without being a data scientist. So by using notebooks, you can enable your applications, your information products to be AI enabled, so it can help non-GIS users to get the most out of those applications for better policy making and better decision making, and to have predictive analysis as an outcome. So it is interoperable. It's not only Esri platform. We are a system of systems. We work with different open science and different tools that can help you. And as I mentioned in my previous slides, this shows that ArcGIS platform connects with many different open science tools, which give you access to many libraries that are available in order for you to do machine learning and to bring big data analytics into your platform and into your applications, in order to have smarter application, in order to get the most out of your data, to get the most ROI of your data, because you're spending a lot of money to acquire this data or to collect this data. And as we've seen here, AI can help you, first of all, to save money from data collection, in order to save money on time, to do analysis and to get the most out of the data, and then use this AI in order to do more machine learning, or to build applications that are AI enabled. And we're going to see that at the end of my presentation today. So what type of spatial statistics and spatial machine learning can be applied? As you can see here, hotspot analysis showing certain trends based on historical data. For example, one of the maps in the middle here, using machine learning, we were able to create hotspot based on historical data on lung cancer and mortality and which area is happening. And hotspots at the bottom map, you can see here, hotspot for heart disease. So based on this analysis and based on this machine learning and this historical data, identifying hotspot for cancer or for heart disease, you can understand the patterns. What is driving this area to be high in cancer? Why is driving this area to have more heart disease? And do some studies and see how you can solve this problem. Moving into space-time, the space-time pattern mining toolbox contains statistical tools to analyze and map data distribution and patterns in both space and time. As you can see here, it's showing a hotspot, like where are the new hot spots or new cold spots? Where are the consecutive or intensifying or persistent hotspot and cold spot, diminishing hotspot and cold spot, sporadic hotspot and cold spot, oscillating hotspot and cold spot. So you can see here, bringing time and bringing space into one place, it can help you analyze the data in 4D. We're bringing here more dimension to the data and to better understand it. Moving to forest-based classification and regression tool trains a model based on known values provided as part of a training data set. So the more you train your data set on known values, this can help you to predict models that can be used to predict unknown values. So bringing known values to train your machine learning model in order to predict unknown values and build data set based on unknown values that has the same associated explanatory variables. So here, some examples of using spatial statistics and machine learning at the same time. Here are some examples about different countries we've supported, like US, Lithuania, we have Ethiopia, we have Oman, and many more that we can also gonna discuss here. We have PSA in Philippines. We have the Central Office of Ireland. They have used ArcGIS to support the dissemination of data. You have PASI Kuwait on the top right. We're gonna more talk about that later on, how they applied AI in their work and their preparation and dissemination too. They have built also Kuwait today. They have built, as you can see, this application. They have built Kuwait Finder. Kuwait Finder is the Google map of Kuwait. So basically today they are relying on authoritative data owned by PASI, which is the Public Authority of Civil Information. And they are now updating their maps, their roads, and people are using their local application to navigate and to see where is the traffic and other criteria. Also, statistics of New Zealand using mobile apps for field assignments, data collection, and operations. Philippines, they embraced GIS to modernize all their workflows from A to Z, from pre-planning to data collection. Here using, as you see here on the screen, they're using operation dashboard to measure and monitor progress of the work. US Census is one of the biggest examples that we can talk here about, because they have so many challenges, including mobile population, constrained fiscal environment, distrust in government, declining response rates. There is a very low response rate in the previous 2010 census activity, increasingly diverse population and informal complex living arrangements. So heading into 2020, US Census better prepared than ever. They have used GIS to establish where to count, motivate people to respond, count the people, and then tabulate, analyze, disseminate the result. So example of ROI. So in 2010, US Census, they have conducted 100%, they have canvassed 100% all the household using field workers and field planning, sending people in the field. Imagine US how big it is. In 2020 round, they have used GIS and GAI capability in order to do an office canvassing. So they were, as you can see here on the left side of the slide, the in-house canvassing, they called it the BARCA, which is called the Block Assessment Research and Classification Application. So this helped the US to save around 66% of the workload done in the field. And they have saved around $2.5 billion by exact number, by applying in-house canvassing and applying GIS in order to update the base map and the building footprint of US. So this is critical here. On the on the left side, at the bottom left side, under the canvassing, there is an application called Drone. They were able during the planning stage to build a response outreach area map, so they can see which area they need to target that had low response in 2010 and how they can increase the response. And on the right side at the bottom, there is something called Census Business Builder. This is a dissemination tool and is available publicly. You can Google it and you can access and play around with this application. It's called Census Business Builder, US Census Business Builder. This can help you and then can help anyone publicly to access that and do some business analysis in order to see, based on the population information, based on income information, and based on consumption information, to analyze where is the best place to open the next branch of a restaurant, where is the best place to open a hospital. All of that is available publicly for anyone to use that tool and use this data in order to make decisions. Moving to UAE, they have used our GAI tool in order to identify all buildings. Not only that, they brought in utilities information with the building footprint that they extracted using GAI, artificial intelligence, in order to identify which building has residents and which household is busy and which household is not busy, based on utilities data and based on building footprint. It's very powerful to bring data together to analyze and in your preparation for your next census. So this is a very strong example here, using meter data and extracting building footprint using AI, artificial intelligence, to do so. Moving to Kuwait, very strong users here, Passy, as we mentioned, they have built their own application called Kuwait Finder. So here we're looking at, on the right side, they have used GIS in order to extract building and roads at the same time. And as you can see here on the left bottom and the middle bottom, there are two squares showing red and blue building footprints. This is showing manually digitized buildings and using deep learning and machine learning algorithm output on the right. So you can see a lot of similarity in that, and how you can make your model very smart to detect buildings. And then you can classify those buildings to become, in order to know which one are commercial buildings, which one are residential buildings, and whatnot. And as you can see here, also using AI capabilities, they were able to identify cars parked on the street, which one are cars, which one are trucks. So even training your model on imagery to identify cars from trucks. So whatever you train the model with, and you can have smart applications that can help you to get the most out of your data, as we said before, and the imagery that you have invested. So get the more products, the more information you can extract from this imagery, the stronger your organization become, the more resilient your government can become in analyzing all of this data. As we have seen before, there are a lot of tools that can be used to do machine learning and open science tools that can be applied in order to bring GIS with those open science to do a certain machine learning and analysis on location, not only on tabular data. This is very strong and important. Moving here, this is a short video that I'm gonna take you through here. It's showing Grenada in the Caribbean. They have done a digital twin of Grenada by doing 3D buildings and by bringing LiDAR data in order to do 3D building, and bringing population data also into this one in order to know which buildings will be impacted if there was a flood that happened. As you can see here on the right side, it's showing if there was a flood of 1 meter, which building will be up. If there was a flood of 3 meters, which building will be impacted. So here you can do predictive analysis to see which buildings will be impacted if a flood happened by building a digital twin of your country and bringing all of this GIS tools and advanced analytics to do so. Also moving here into, I'm gonna move fast forward on this one a little bit. Here showing some landslide risk to see which buildings are built on landslide risk areas, and in order to make sure that, to know which buildings or which population you need to go evacuate in case of a disaster, natural disaster. Also bringing the population data into that, you can know where are the handicaps, where are the elderly living, and which buildings you need to immediately go and evacuate and send the needed support in order to evacuate them and help people to save more life when any natural disaster is happening. Now moving into, so using here our GI capability, we move faster here. Okay, so we were able to extract building footprint, also using tools to do enumeration area delineation, and identifying each enumeration area by using our territory design tool. And this is all automated, and then bring that into your field application to send people on site. You can see it in an inbox form, as you can see here in Grenada. So the enumerator can use it in an inbox form, or he can switch to a map view, and he can see only buildings assigned to him, and only he can see the enumeration area that he's assigned to. So by looking here, the enumerator will go to a certain building, will start filling the form, and then by click of a button, after identifying, he can then send now, and he uploaded the data and he collected data on this one. Then because this data is available as a service, it's updating the dashboard for decision makers, for supervisors, to see how many buildings has been completed during the survey. So this is the power of, as Oliver mentioned, the power of integrating GIS with statistical and the statistical or the census workflow. So let me move forward on this one. Now, this is something big coming soon within our tool, using natural language in order to query data. Decision makers are non-GIS users, as we said before. That's why we build information product for them. But not only that, our decision makers today and politicians, they don't even know how to use sometimes technology. So they need to write and talk using natural language, using ChatGPT. So we're bringing ChatGPT into our platform. So by having all the data and services like images, tabular data, feature services, and then using all these open science model that we spoke about to train the model with the data that we have, and then bring this capability into our survey 123 that we have seen, our hub, in order to use natural language to talk to our to the map. I'm going to show you an example here, a video recording of this prototype. So by using natural language, so saying, I'd like to make a map, starting with that. So the hub will bring what are the layers that are available. So it will first of all open for you a base map, and then you can type, do you have layers for wildfires? By writing using natural language, using OpenAI and ChatGPT capabilities, it brings you all the layers that have wildfire. You can tell her, please add the second layer, and it will add for you the second layer available on the right side of these layers. And then you can see them, it's added on the map. And you can start also asking questions, how many wildfires you can use to count also. And you can use all of this by just chatting with them. Imagine how powerful is this for politicians and for decision makers to use it instead of using the mouse or keyboard to query the data. Just type natural language using OpenAI, and this is where our partnership with Microsoft is very strong as Esri. So how many wildfires are there? And the most important part of here, and many people here on the call, they're asking if this can be in French. So this supports all languages. And we're going to see later on in the video here, switching into different language to Spanish, or switching. And here, still showing like you can also ask to make 3D maps for you and whatnot. And then moving here to writing in Spanish or in writing in other languages. I think this is Mandarin. I think it's Chinese or something. Anyway, this is showing the new upcoming AI capability in order to have AI assistant to chat with your map and get layers added and query. This is very powerful for decision makers and for for non-GIS users. Here, I just wanted to kind of show you also how powerful and how advanced you can do how much is advanced to do mapping and building digital twin. Here is an overview of Boston City, and it's showing roads in 3D. It can show also building in 3D, and not only that, I don't know if you're familiar, and we said that GIS or ArcGIS platform can ingest many different type of data, bringing BIM, the building information model, as you can see here, into the data. You can also you can see the map from outside. You can go inside the building and see each household information. You can link the household survey information that you collected with the household inside. So you can know how many people are living in this building, in each floor and whatnot. You can also symbolize your buildings based on age or based on current status of the building. You can also see underground utilities. So this is what we call digital twin, and this is the power of mapping and the power of the platform. So I wanted to fast forward here quickly to show you here, using our gaming engine, how you can also design a city and make it more real. So this looks like a real city and real cars. It's all using our gaming engine technology to see how the city will look at night, bringing population data into that to see how to better design your roads to avoid traffics, and where is the best place to build a park based on the population and the different age and all of that. So all of this predictive analysis can be applied, and using 3D and and using 4D, we're using time also into that. So this is very important. So to end up here, I will move into, we have, if you want to learn more about use of GIS, we have our book called GIS and the 2020 Census, written by my colleague Linda Peters. And we have also our official statistics modernization webpage. And we have a lot of free training available for people to learn how to use the platform available. And I can share those links with the organizers here in order for you to have access to it. And let me just finish with something here. I would like to also invite you all, and as I said before, I already shared this with Oliver previously. We have our Africa GeoPortal. It's free to use. It's mainly built for Africa, for different communities and different mapping agencies, or even for people to learn how to use the technology. They can access many tools here in order to learn how to apply GIS in their workflows. So thank you, everyone, and I'll stop here.
Thank you, Richard. Thank you, Richard. As you were presenting, I was contemplating myself that if I was not advanced in age, I think I would have changed my career. I was going to change my career. Really, this has been excellent stuff, huh? And really big hands of applause to you, as you can see from everybody. This is excellent. I think it's mind-boggling. Thank you so much. It's really amazing to hear how GIS and the modern GIS tech architecture, which has been helping everyone to do their work better by leveraging on the services for improved sharing and collaboration, and engaging everyone while ensuring that information can be distributed and information action should be interconnected while respecting individual privacy and the fundamental principles. So I think you've explained it so well, you know, in terms of the, first of all, the artificial intelligence, how it's playing its role, particularly in processing and you know, the analysis of all data streams from statistical to geospatial. So that data integration is really very critical. And thank you very much for making that easier. And I think this is what policymakers want to see, colleagues. Rather than having to give them text and numbers and numbers, I think if we can give them an overlay of this map, like what Richard has done, makes it easier for policymakers, rather than having to send a 50-page document of text and numbers wouldn't really be very helpful to them. So I would like to open the floor for questions. I do have my own questions, Richard, just to warn you, in case there are no questions, because you have said so many good things here. We have 112 people, and I'm sure they have questions. Colleagues, I also want to apologize that we don't have a French interpretation. And the reason for this is because each time we run a thing like this, we would pay not less than 3,000 just to get someone to come and do the interpretation for us. So we're still looking for sponsors who can you know, help us pay for the interpretation. So we're sort of very selective which ones we get interpretation and so forth. So we are not neglecting other languages just because there's a cost associated. So if you have an idea where we can get the money, we'll be more than happy to receive that you know, that support. So any question, please raise your hand and unmute yourself. I'm sure you have a lot to say, because I haven't seen anything in the chat yet. I've not seen any question in the chat yet, other than asking for the presentation, which will make them available. But let me say this, Richard, while waiting for people to ask questions. First of all what you have said is really nice and very interesting. I'm asking, you know, as these large language models based on tools have become more public and available for widespread use, awareness has risen for their potential to disrupt society in both positive and negative ways. And they are even caused to pose further developments while society at large, you know, takes stock of what's being created. So perhaps, you know, in your own view, you know, what would you say in addition to what you've already said in terms of how best can these facilities also be accessed by countries, particularly developing countries that don't have resources? Most of the countries that we showed, you know, Middle East, these are countries that have resources. How do we support countries? I know you're doing some work in Ethiopia, but how do we scale up that support to other countries?
Yeah, exactly. So one thing is that we have many people might know about that. We have first of all our modernization program, which is we have identified along, and we have this partnership with the UNFPA. We have identified developing countries to provide them our technology in order to have access to all of these advanced tools in order to support them and getting access to the full technology to support their census activity, to support their analytics. So the current program has technology that is worth of more than $1 million, and it's funded by UNFPA, and we're providing that providing that for 4 years access, and it's perpetual license. At the end of the 4th years, the license will not expire. And having said that, it is only for $40,000 access to all of these tools that I just showed here. So some people will decide, and it's not wrong. I'm not saying anything is right and wrong here. Some organization might go because of low funding, might go for an open source technology, but the amount of money that they need to spend in order to customize that and maintain the tools that they have built, it costs them much more than $40,000 that Esri is providing, and providing that with maintenance for 4 years, access to our technical support for 4 years. So this is how we're supporting developing countries, by giving this special bundle and special price for developing countries. And we have we have around 46 so far countries that they have adopted, and they did not have fund to purchase the technology they were able to purchase that and use it in their census activity.
Thank you, Richard. Richard, and there's a hand from Rehema very soon, but you'll answer my question along with what Rehema is going to ask. How can we help as ECA? You know, we have a convening reach to all 54 members of the UN in Africa. And to some extent, we also know their capacities and so forth. So how can we help these countries to reach out to, because some of them may not even know that there is this possibility that you are offering as Esri. But you answer the question along with the Rehema. Rehema, you've raised your hand. Can you ask a question? And please, if you could just unmute yourself and put the camera on so that Richard can see you.
Yep.
Okay, right. Can you hear me? Can you see me?
We can hear you. Thank you.
Yeah.
Okay, so thank you very much. This was a wonderful presentation. My question is specifically towards the gaps that we have in the climate change and towards addressing climate change issues. And we are seeing that these issues are finding us off guard. A lot is changing within a very short time, and it's taking a lot of time to obtain all the data that is needed to address these issues. And it's great to see that Esri has advanced over the years. And now my question is, how best can we use this technology to embed with the existing other platforms and softwares out there to be able to address these gaps in a more efficient way? Thank you.
Perfect. Yeah, that's a good question.
Yes.
Thank you for asking.
Yeah.
Yeah.
You can take both questions, Richard. My question and Rehema's question.
Okay. Sorry, can you repeat the first question? Sorry, I got.
Oh, sorry. My question, Richard, was on the first one was that the countries. First of all, I said that we reach out to all 54 member countries in Africa, and I think we have that comparative advantage compared to other Pan-African institutions. And I'm wondering how we can scale up, how we can help work with Esri to popularize and let them know that there's this possibility that you offer at Esri for them to access these tools.
Sure. So we have if you Google Esri, and I'm going to share that link with you, Oliver, after this call in the email. We have our page for the official statistics, which have access to all material and all countries that have access to this modernization program. And countries can, once they access to this link, they can apply for the modernization program. It will come to me, and I can approve it based on the countries that we have listed based on our agreement with the UNFPA. So I can share that link with you, and if you have access to all of these countries, you can share this link so they can see if they are eligible for the program. If not, we can work with you on seeing like what's the current challenges and to see how we can provide them with more support. And also, as I said before, we have the Africa Geo Portal. It's free to use. Anyone can go and create an account here. And we already proposed that to the Young Statistician Organization under ECA during the IAOS to access that and to learn how to use GIS as young statistician to do so. And also we promote that for all statistical organization or mapping organization in Africa to access the Africa Geo Portal and to use that. There are a lot of free training material. So you have the technology, the software for free, you have training material for free, you can access that, use it, build maps, interact with the maps, and learn how to apply GIS in your workflows and your day-to-day activities. So I hope I answered your question here, Oliver, on the modernization program and on how other countries can access the technology and get free training on that.
Okay. Rehema, are you happy with the response? I think your question was about access to tools, somewhat related to what I asked. Are you okay, Rehema, with that?
I think her question also was related to collaboration, right?
Yes, it was. No, I don't know if there are any more questions. I don't want to have a monologue with Richard, but I do have a question, Richard. While we are waiting, the colleagues to ask the question. Now, the genie is out of the bottle, Richard. What are the implications of geospatial services sector? These machines can generate code for faster and possibly more accurate than any human software engineer. But are the answers it gives really correct? What are the legal implications if the code is flawed? What about the IPR? Is this a legal infringement? I mean, what are your thoughts on this, Richard?
Sorry, can you more leverage? Can you more expand on that? What exactly the legal part?
So the question was that, you know, some of this, when you use some of these machines and you find out if perhaps you generate certain codes, I mean, you generate certain information because of the information that you have, how can we really certify that the answers it gives are correct? And whether when it gives the wrong information or even when it gives information, as we will come from the official statistics, could we say that these are, you know, there could be legal implications, especially if, you know, it's also associated with codes that are flawed?
Yeah. So as I said before in the slides, that in order to reach to that level of accuracy, at a certain level of accuracy where you can apply AI and be confident with that, there is a lot of training and labeling that should be done. On top of that, adding the layer of doing validation. So we never go with AI blinded without doing any validation. So by doing validation and keep on training the model, even the model can tell you how accurate it is, because there are some manual entry and there are some outcomes that was extracted using the AI model. So by bringing the manual work that your team or the field worker is bringing here, the model can compare between what was generated by the AI and what was generated by a human. And it can give you what accuracy today is your model is at. It can tell you, well, you are at 75%. No, I don't want to give this AI tool for my for someone in the government and tell them, well, use this tool because it's 75% accurate. This is gonna be a problem. I'm gonna keep training my model and doing more validation until it reaches to a certain like 95-96% of accuracy. And it shouldn't be always, we shouldn't rely 100% on artificial intelligence. There is always a human intervention here. So once you get results, you have to validate that before you provide it to anyone. So, but this can fast track you to get the results and get the answers and get the outcome. And doing some manual or human check, it doesn't consume a lot of time anymore in order to do so. So having combination between AI and human validation is key and important.
No, I think that point is very, very important. That, you know, as we use artificial intelligence, we must know, at least have an idea of the expected answer. So the validation part of it becomes very, very important so that we don't lead ourselves astray. And that's very, very critical. These tools can be easily misused if we don't know what we want or even what we expect out of it. I mean, they are supposed to facilitate. Instead of doing something for 2 days, you do it within seconds and you're done. And that really makes the difference. I do have some questions, but we have a hand from Joseph. Please, Joseph, go ahead and ask the question. And then also, I think we have Abera. So Joseph, and then Abera.
Okay, thank you, Chair. Richard, thanks a lot for your very well presented article. I was just wondering, we in the 2019 census, we used a method of the GIS 2020, and now you are saying we should download the book and maybe make use of it. Has it not been overtaken because we are now looking at GIS in 2030? Has it not been overtaken? Because the way we were trying to identify, I saw you very fantastically illustrating on how we can identify the structures and the households. And remember, we do census looking for where people are. Where, of course, they are in the structures in which you are showing. We actually used the GIS, the US Census GIS 2020, and now we are looking at 2030 censuses.
Was that a question? Sorry. I lost the sound.
I'm muted. Joseph, I don't know if you completed your question, because I think you're referring to now and also for 2030 in terms of the census. It wasn't clear what the question there is. Would you want to repeat the question itself, Richard? Sorry, Joseph.
Yeah, I don't know if I understood that correctly, Oliver, that he was saying that I was referring to the 2020 census book, and isn't that like now predate, like exactly. The methodology is explained as like old now because they're looking at 2030, so maybe things have evolved as we have showed now in the presentation. Definitely, yes, I can say yes, but it's still like, the book is talking about very advanced tools that was used in 2020 census, that it can be always something that can help you in your preparation for the 2030. So a certain percentage definitely will be changing. As we said, digital transformation technology keeps on evolving. So a book that is 3 years old definitely doesn't have all the new stuff that we are currently facing, and the technology where is it today. But I can say that it is still very close to where we are today. So we did not yet move very far from what was written in that book. So it's still showing like also how to move from traditional data collection using CAPI or PAPI to doing more administrative census, and saving also a lot of money from sending people on site and bringing thousands and thousands of enumerators and buying thousands of devices and buying thousands of licenses and buying an MDM software to manage all these devices. So moving to administrative data is also covered in that book. So it's still kind of touching base on futuristic stuff that will be coming in the future. So this book is talking about also future initiatives.
Two more questions, Richard, before I ask my own. I'll serve you and then Eileen. The question by Andre, I'm going to link it to my question, was quite similar to what I'm going to ask Richard. But first we start, I'll serve you and then Eileen. Abera, I'll serve you, Abera. Okay, Eileen, maybe go ahead and ask the question. Asaf maybe is trying to find a way of unmuting. Eileen, please go ahead.
Okay, good morning, Richard, and thank you for the presentations. Was very good. Just one question, like I think the usual concern in using preset tools such as those that are developed by S3. I know it's very powerful at the moment, but in terms of cost, you alluded to it not being costly in the long run. But as the question, linking it to the question of Joseph, I just wanted to find out in terms of updating the tools, how much resource are required in terms of retraining and financial would be involved. Because as I understand, the 2020, it may not be useful for people who are in advanced in statistical development, like but for a lot of countries with still very which are still at that stage of statistically developing, so this may be useful, but the cost implication of updating the tool and retraining and even changing the whole infrastructure. How does ESRI prepare countries and regions for this? Thank you.
Okay, thank you. Yeah, that's a good question. And for me, I see that, and based on our experience, that today customers or organizations that are still that buy ESRI technology, which is, I can say that ESRI technology is not for free. It has a certain cost label, and sometimes it is considered expensive for certain countries. That's why we have special bundles for certain countries. So we are very flexible and supporting certain countries in order to meet their budget. On top of that, the cost of maintenance. This is where ESRI is called a proprietary software. By building your own tools and customizing your own tools cost more money to maintain them than purchasing a proprietary software on the long term. Because ESRI is spending 30% of its revenue every year in order to do R&Ds and update the technology to meet the latest security aspect, the latest technology trends. And by advancing that, and while we are advancing our technologies, because we believe that, and as I touched base in my presentation, the more you are on configuration and not custom application, the more it's easy for you to move and evolve with the technology. The more you are custom, you are stuck in the past. And the world is evolving to cloud, is evolving to digital twin, to AI and machine learning. Once you build something that is custom, you need to migrate that to, in order to meet those future stuff. You get a lot of struggle to do so. It costs you a lot of money to do so because you need to rebuild your application, change all the back-end code in order to meet the future requirements. So by being on a proprietary software, ESRI is evolving this, and you are under maintenance. You get those updates automatically, and it's pushed to your system, and you can easily move from a version to another version if you are not moving into customer. The more you are on configuration side, the more you can evolve your technology and move with the current technology trends, and at only paying maintenance for ESRI. So there is nothing for free. People think that going sometimes and building their own tools is for free. There is nothing for free. There is no system for free. So this is something should be clear for everyone.
Yeah. No, thank you, Richard. That's very true. Nothing comes free, and anything that is free is dangerous. It's very dangerous. If someone gives something that's for free, be careful that there's an agenda behind it. So be careful to get some free food. Yeah. So, Safi, do you have a question? Please, the floor is open. Otherwise,
thank you, Oliver.
Okay, go ahead, please.
Okay, thank you, Oliver, and I've been following with the presentation by Richard. Really, I saw how GIS and the artificial intelligence has moved forward in the different streams. Coming to my question that you have explained, instead of a single dashboard, it is good to move forward by an enterprise approach you have mentioned earlier. So according to the principle that we have been abide for statistics is confidentiality. If you are moving everything from design to the dissemination to an enterprise approach, that may have a concern on confidentiality and data security. So how we can ensure or also build trust in the National Statistics Office in making their data more safe, confidential, for their statistical business process they have been following. Thank you so much, and I'm back.
Thank you for the question. That's really nice question here. I'm happy to answer that. So as you know, security has different layers. You have the data security, you have the application security, and you have the infrastructure security. So depend first of all where you're implementing your enterprise solution. And by having your data available on enterprise solution available as a service doesn't mean that that people can access your data or download your data or do anything with your data, because the portal is very powerful in order to build governance around your data, who can see it, who can edit it, and who can download that. So first of all, the first security aspect, if you are implementing RGS platform on your own servers in your IT department, then we provide you the right architecture, okay, in order to have a secure environment on premise. If you're implementing RGS platform, because there are different type of deployments. If you're implementing RGS platform on a cloud inside the data center in your country, there's also a certain architecture that we can help you with in order to be secured. And if you're doing public cloud, which is, I think it's a very I don't think you would look for that, because it's going to be, your data will be available outside of your country, and this is currently not the recommended approach for most of statistical organizations. I can tell you that on the application layer, which is Esri applications, it is very secured, because our enterprise solution that you are using for statistics is being used by US Army, Defense, by police, by all of these very critical, having critical system and critical data about people, about IDs, about information. So our enterprise GIS we've been in the market for the past 53 years, and we've done a lot of R&D, and basically it is the most secure platform today in the GIS market. That's why we are leaders here. And definitely bringing our expert to help you in architecting the solution to be secured on the data and application and infrastructure level is important. So I hope I answered your question, but the security aspect, we take it very seriously at Esri, and this is where we differentiate ourselves from others.
Thank you. Thank you very much. I see two more colleagues before we wind up. Willis, good to have you, and James. Can we start with Willis, please? Can you unmute yourself and put a video, put your camera on, please, Willis.
Okay, thank you. For a while I was disabled, so I didn't know how to do this. Thank you so much, Oliver, and greetings from Cairo. Thank you, Richard. I was quite impressed by your presentation, and you made a reference to the Memorandum of Understanding between UNFPA and Esri. But I was also quite interested by the presentations you have from the Middle East countries, Kuwait and the like. And I wanted just to check the extent to which you are getting direct requests from governments, not through UNFPA, and the likes of those Middle East countries. Are they paying the full cost for this, or are they also negotiating as well? Because that has implications for the earlier question Oliver made about just expanding a wider access to this. So if you're able to comment briefly on those, thanks.
Sure. So first of all, we have the agreement with you as UNFPA, which is covering a certain amount of, a big amount of countries in all the regions from Latin America, Caribbean, mainly a lot of countries in Africa and Asia, and some countries in the Middle East. On the other side, we have special bundles that definitely more expensive than the modernization program, that is based on countries that were not covered by our agreement with UNFPA. And as Esri, because we are a privately owned company, we're not a sales organization. So our list price, if you go online and you check the price, you'll see the price is expensive. But have you spoke to an Esri representative to see like if we can discount and help you with your budget and meet this expectation? We usually are very flexible by doing so. So in the Middle East, some of the countries like Saudi Arabia are well funded, and they have enough funding and money, and they spend a lot of money on technology. Sometimes they don't even ask for negotiation. They negotiate. Sometimes we provide them discount, but definitely not a discount that we provide to developing countries. So at the end, we need to sustain the business as Esri. We need to support at the same time. And Jack Dangermond, which is our CEO, would like to see the GIS used in order to solve problems around the world. We donate our software. We provide a 24/7 disaster response. We have a disaster response program team that are 24/7 available. And I would like you all here to know that anytime you have any disaster response from flood, hurricanes, or earthquake in any countries, and Oliver, it's to you being as ECA, please reach out to us. It's a free service. We bring all the data, we bring all the tools, and we provide that for free in order to help you respond to any disaster happening in your region. So it's a free service, 24/7 available within Esri. So to answer the question here, the price can vary from, we have a fixed price that is available. You can see it online, but we are very flexible with discount, and we have agreements with the NFPA. We have other bundles to support different countries based on their their capabilities and how much they can afford to pay. But we want to make sure that the technology is available for anyone at any cost.
Thank you for that offer. Andre is on the call, so we're taking note of that offer. James, could you come in as well now? James, it's a colleague by the name of James. Yes, please. Yes, go ahead.
Thank you. Great. Thank you very much for giving me a chance to talk. Thank you for the great presentation from Sir Richard. I am a Kenyan. I come from Nairobi. I have only one question for Richard. During the era of artificial intelligence and machine learning and training the models, is there a way, or is there an AI tool which can be able to distinguish between structures which are residential and others which are not residential or commercial structures, or maybe offices structures? I would wish to know this because currently we are in the phase of carrying out a housing survey, and it will be great in case we can be able to distinguish between the two structures of residential and residential as far as the dataset is comprised on a high resolution satellite image.
Thank you very much. Thank you. Yeah, that's clear. So basically, applying machine learning is like you are teaching a kid, or like everyone, most of you might know, like a kid us as a human, we are born, we don't know how this bottle, that this is a coffee bottle or a coffee cup. Okay, so you start telling your kid that this is a coffee cup, but if you switch it and you show it in the other direction from here, he will not identify it. And this is a coffee cup. This is a coffee cup. This is a coffee cup from all angles. You're teaching the brain how the coffee cup looks from different angles. Okay? And by doing so, you are increasing the accuracy of that kid or that human being to when they see a coffee cup from any angle, they will know that this is a coffee cup. Same thing you can apply for machine learning for the computer here. So if a residential building and a commercial building in Kenya, they look different from a satellite image, you can teach your machine to identify that this is a commercial, this is a residential building. And also you can combine different methodologies, not only by applying satellite imagery. Also, if you have enumerators, or if you have the field people or cars, vehicles driving on the road that have cameras like LiDAR or stuff that are capturing buildings from the bottom, you can build this 3D. As I showed the capability of 3D, you can know that a commercial building usually doesn't have balconies, for example. So you can start to teach the machine that any building that does not have balcony is a commercial, but sometimes a residential building might come with no balcony, and this might be an error here because the machine will think this building is a commercial. So the more you bring different data sources from satellite imagery, from pictures, from other authoritative data sources and you train the machine, the more your model becomes smart to identify that. Maybe satellite imagery alone is not sufficient for you in Kenya to identify commercial and residential building only from satellite imagery, because from the top, they all might look the same.
Yeah, thank you. Thank you. Richard, the last question for me and close, and you've spoken quite a bit. James, do you want to make a follow-up question? No, you're good? Thank you. No, Richard, very quickly, you somewhat maybe may have addressed this question in your presentation. I know Andre also somewhat has a similar question to mine. As we close, Richard, can you just think about or provide us some hints or joint pointers in terms of what would be the concrete ways in which we can strengthen the role of GIS and artificial intelligence to support the policy goals in Africa in particular? What really works best? And related to that question, really, I would like you to also talk about, what do we need, in terms of to set up artificial intelligence on the continent in particular? What kind of situations should we be thinking about? What areas should we be focusing on to really apply artificial intelligence appropriately on the continent, given all these technologies that are available?
Yeah, it's as simple as that. My answer is that you need computing power. That's all what you need. And the technology and Esri provide you, and you don't need a data scientist to do so, because we have out-of-the-box trained models that you can take, and anyone can learn how to train the models and apply it, but you need computing powers, because you need very strong GPU in your machine in order to use satellite imagery to identify buildings, roads, and cars, and solar panels from an imagery. So you need GPU power. So, and you need computing powers like from RAMs, CPU power, and all of that in order to bring all of this data, big data, and analyze it and apply machine learning on it. So computing power is very important. So maybe partnering with cloud providers is very important. Also, we can support you if you want on providing you, and if you already, I think you have access using our SaaS technology. So instead of you investing and purchasing and buying infrastructure, you can use RGS Online, which provide you all this computing power in order to apply and use the SaaS capability that is scalable and can help you to apply machine learning. So as a starting point, starting with SaaS, this will be the lowest investment. And I think as ECA or as UNECA, I think you guys have already our license, and you should have, I'm not aware yet, but Andre can clarify that. You already have RGS Online organization that you can leverage and use in order to start applying machine learning on a certain pilot area, learn how to apply it, what things you can extract, what things you can get out of this capabilities and this advanced tool, and then start to expand that to a country level and then regional level. So using our SaaS technology, which you already have in hands, I think this is the good place to start.
Yeah, no, thank you. Good pointers, Richard. No, we've come to a close of this, but I want to quickly just point out one critical thing from what you have said. I think you talked about a combination of human validation, check and train the models are key to increasing the accuracy and the quality of data and statistics produced. I think that's important, that we should not use artificial intelligence just for the sake of it. We need to make sure there's a combination. There's human intervention is very critical, and I think that's key, colleagues. And I quote Richard for that. So thank you so much, colleagues, for the questions. Those that were able to give questions, and I'm sure others they're still burning, and perhaps they will be sending emails with questions to us and also to Richard. So today's webinar really enforced the need for providing access to information as the first step towards a more inclusive and just society. The presentation that we've heard, from Richard, this morning really recalled the innovative technologies are central to any effort of sustainable planning, management, and monitoring. And because just spatial science and technology can be utilized in virtually and all situations, and human activities that are spatially distributed, it becomes more and more integrated into the main aspects of contemporary life. So geospatial information technology, really, and artificial intelligence, what we have seen, are cutting edge. There's no question about it. It's cutting edge technology, and the next technology, the next technology revolution in the world. It's evolving all the sectors. It's not excluded to certain sectors, but this involves everything, as you have heard, and he showed you from the earlier slides which areas and which ones he himself is actually involved in, and therefore I think there's need for us to be able to create and maintain the capacity in member states. The offer is there. Richard has told us how we can get some of that offer. For us as ECA, there's also need to consider geospatial, and here I'm speaking to colleagues that run this, to consider really geospatial information across sectoral consideration and become a crossing-cutting edge in all pragmatic domains, because it has become obvious that enabling these capacities and technologies in all domains it's necessary, and we have to do it. We don't have a choice with that. So as we conclude, I would like to again thank Richard for this very useful, insightful presentation, as you have heard from those that spoke, that they found this presentation very useful and will be sharing with everyone. And therefore, I'd like to invite again one more time that are connected here, please, a round of applause to Richard for the excellent presentation that he given us this morning. So I want again to thank you for joining us today. We will be having a similar presentation somewhere around the week of December 12th. And this time we'll be discussing a little bit more about understanding the contribution of South-South cooperation to SDGs. That will be focus. That will be the focus at the time. So, Richard, don't be surprised if we come back to you. We come back. I'm ready anytime. This has been very insightful, and I think the more you talk to us, the more you think about these things. I think the more we even think. I was telling you that I want to change my career. If I had a couple more years to, I would have changed to become a geospatial person, because this is really mind-boggling, very intriguing stuff. So I hope everyone enjoyed this webinar, and all the very best. And we'll talk to you at some point. Richard, we'll be in touch. And thank you very much to everybody that is here. All the best.
Thank you, everyone. Yeah. Thank
Oliver,
you.
Can we have a picture of a group photo? If some people who are still here can open their camera. Thank you.
Can we unshare? I think this is the presentation by Richard. Can we unshare it? There's still a presentation, a slide there. If you can share it,
okay.
So that we can have a picture. Please unshare that.
Yeah.
Unshare it.
Yeah. If you can unshare, thank you.
Yeah, but it's still on the screen. If you can remove it.
Group photo.
Okay, that's better. So put on your cameras, colleagues. Can see all the beautiful faces here.
Nice.
Okay.
Nice. Good to have everybody here. This is really good. This is good. This is good.
Yeah.
Yeah.
Smile at everyone.
Yeah. These are the transformers of the continent, because they're all interested in artificial intelligence. As long as you use it properly.
Thank you, Chenaya. Keep it up. You're a very nice guy.
Okay.
Oliver,
thank you.
You're doing a very good job.
Thank you. We appreciate that. Okay. Bye.
Yes, bye.
Bye, everyone.
Thank you, everyone.
Goodbye. Thank you, Richard.
Thank you.
Bye. Richard, you have 112 plus speakers listening to you.
Richard, very good. Yes.